Hey everybody, Mr. Antonucci here, and in this video, we're diving into the 2025 AP Stats free response questions. Whether you've already taken the test and want to see how you did, or you're prepping for next year, this walkthrough is for you. We're going to talk through some of the key concepts, some strategies, some common mistakes, and most importantly, solve the problem for you. Question number 3. This is our probability and binomial setting question. Part A was a straightforward process of finding basic probabilities. Part B took it to a binomial model, and Part C added depth by using binomial methods and then having to explain some things there. That last part required some thoughtful reasoning because you had to discuss expected variability and recognize that 4 isn't actually that surprising. This is the first time you really have to make some calculations on the AP exam. So part I, I'm going to put right here. Suppose one song is selected at random to be played. What is the probability that the song is a rock song? Show your work. Well, we have 1,000 songs total, and 100 of them are rock songs. So that would be 100 out of 1,000, which is zero point 0.1. Part 2, suppose 2 rock songs are selected at random. What is the probability that both songs are rock songs? Here's something you have to consider. It says any song can be replayed at any time, meaning this is sampling with replacement. So you would have 100 over 1,000 times 100 over 1,000, not 99 over 999, which is going to give us 1/10 times 1/10, or 1/100th. So part B, every 1 hour period, 20 songs will be played at random, and any song can be replayed at any time. Mrs. Fay is interested in how many rock songs will be played in a typical 1 hour period. Define the random variable of interest, Mrs. Fay, and state how the random variable is distributed. What is the expected value for the random variable in part B? Show your work. So for part I, we're going to define it as X. You could use Y or W or capital R. Typically, we're going to use capital X, and it's going to be the number of rock songs played in 1 hour. Also, we needed to state how the random variable is distributed. So we need to add that X is binomial with N equals 20 and the proportion of successes equals 0.10. Now, for part 2, the expected count is just going to be the number of trials times the probability of success, which you can get that's on the AP Stats formula sheet. So here we just do 20 times 0.10, which is 2 rock songs. It's helpful to label your answer. Moving on to part C, recall that in every 1 hour period, 20 songs will be played at random, and any song can be replayed at any time. Part 1, determine the probability that 4 or more rock songs in a particular 1 hour period will be played. Show your work. So we would write the probability that X is greater than or equal to 4. Now we can do this on the calculator with the binomial CDF, but remember the cumulative density function always does the probability of that value or lower. We would have to do 1 minus the probability of X being less than or equal to 3. So this is going to be 1 minus binom CDF with N equals 20, P equals 0.10, and X equals 3. This would give you 1 minus 0.867, which is 0.133. So even if you do the binomial CDF on your calculator, you still have to write down the notation there to get full credit. Part 2, suppose 4 rock songs are played during a particular 1 hour period. Does this provide strong evidence that the song selection process was not truly random? Justify your answer without performing an inference procedure. Assuming that this process is random and there is a 0.133 probability that 4 or more rock songs get played, that would not be surprising because 0.133 is greater than a significance level of 0.05, which is typically the significance level we use when one isn't stated. So we have convincing evidence that the song selection process was not truly random. So I'll write that out for you down here just so you can see it in a concise statement. So there I have it for you. And that finishes problem number 3. Now, overall, the 2025 FRQs hit all the big ideas, comparing distributions, experimental design, probability, inference, and communication. So let me know in the comments which question you found the toughest or the most interesting. And make sure you hit that like button and subscribe so you don't miss any more videos that I'm putting out. Thanks for watching, and I'll see you in the next video.